What is the most powerful thing in the universe? The question has haunted humanity since the first eyes turned upward, tracing fire across the night sky. Two ancient watchers. A comet was a blade cutting through the heavens. Supernova, a god's anger bursting forth in flame. These were not just lights. They were omens, mysteries written in fire and silence. Power was not yet measured, only feared. Centuries passed, and the sky was no longer only a canvas for myth. A man named Galileo lifted a simple tube of glass to his eye, and in that moment, the heavens cracked open. Moons circled Jupiter. Stars multiplied into endless hosts. The universe was not fixed, nor perfect. It was vast, restless, alive. Then came Newton, who bound falling apples to falling planets with an invisible tether. Gravity, a force both patient and absolute. With his equations, the Earth itself was no longer center, but a wanderer held in orbit by an unseen hand. But even Newton's cosmos was just a beginning. Einstein arrived, and with him, the revelation that space and time themselves were woven together, bending under the weight of matter and energy. The fabric of reality could ripple, twist, and collapse. The universe was not a stage, but a player in its own drama. In these moments, humanity glimpsed the scale of cosmic power, forces that could shape galaxies, ignite stars, and bend the geometry of existence itself. And with each discovery, a quiet realization grew that whatever power rules the universe, it is beyond anything earthly imagination had ever conceived. For centuries, the heavens had seemed eternal. Stars appeared constant, unchanging, their light steady across the lifetimes of empires. Humanity once believed that the night sky was a sanctuary of permanence. But science would reveal that beneath that calm, glittering surface, the cosmos was a stage for violence on scales so vast, it strained the limits of imagination. The first shock came with the recognition of stellar death, a supernova. What seemed like a single star, steady for millennia, could suddenly erupt in an explosion so fierce it outshines its entire galaxy. For days or weeks, a single point of light can burn brighter than billions of stars combined. It is not merely destruction, it is transformation. In that instant, elements are forged: carbon, oxygen, iron, gold, the atoms of human blood, the iron in our veins, the calcium in our bones, gold that adorns our temples, are born in these final breaths of dying suns. Yet the power required to create them defies comprehension. In the span of a few seconds, a single supernova can release more energy than the sun will emit in its entire 10-billion-year life. Astronomers watching these titanic detonations were forced into humility. The sun, so central to life and worship, was no longer the ultimate measure of power. It was fragile, ordinary, a candle next to a furnace. The sky was not calm. It was alive with endings. But even supernova were only the beginning. In 1967, radio astronomers Jocelyn Bell Bernal and Anthony Hewish detected a signal that seemed almost impossible. It was a series of perfectly regular pulses, arriving every 1.33 seconds, with a precision sharper than the finest atomic clocks. At first, the researchers suspected something artificial. The repeating pattern was so exact, so unyielding, that it earned the nickname LGM Little Green Men. But the source was no civilization. It was something far stranger. These pulses came from neutron stars, the compressed corpses left behind after a massive star collapses. Imagine the mass of the sun squeezed into a sphere barely 20 kilometers across. The matter within is so dense that a single teaspoon would weigh billions of tons. These stars spin at dizzying speeds, some rotating hundreds of times per second, sweeping their radiation across the galaxy like lighthouse beams. To encounter such precision from such violence was a revelation. The universe had not only destruction, but rhythm. The echoes of catastrophe turned into celestial clocks. If neutron stars and pulsars revealed one frontier of extremity, quasars unveiled another. In the 1960s, astronomers searching the skies with radio telescopes found objects that defied classification. They looked like faint stars, yet their spectra showed redshifts so enormous that they had to lie billions of light-years away. Their brightness was unimaginable. Single quasar emitted more light than an entire galaxy. Yet all of this energy seemed to come from a region no larger than our solar system. What could possibly produce such power? The answer was both shocking and unsettling: black holes. For centuries, the idea of black holes had lingered as a strange mathematical possibility in Einstein's theory of general relativity, a place where gravity becomes so strong that nothing, not even light, can escape. Most physicists dismissed them as curiosities, too absurd to be real. Nature, it was thought, would not permit such monstrosities. Quasars demanded an explanation, and only black holes, feeding on and falling matter, could account for their brilliance. As gas spirals into the abyss, it heats to millions of degrees, releasing torrents of radiation. The paradox was unavoidable. The darkest objects in the universe could also be the brightest. This was a shattering realization. Black holes were no longer speculation. They were engines of galaxies, sculptors of cosmic architecture. At the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. Millions or even billions of times more massive than the Sun. They are both creators and destroyers, nurturing the growth of galaxies through their gravitational dominance, yet capable of devouring anything that strays too near. Each of these discoveries, supernova, pulsars, quasars, black holes, carried with it a kind of existential shock. They forced humanity to admit that the cosmos was not gentle, not stable, not a realm of eternal light. It was violent, dynamic, and perilous. Our solar system, seemingly calm, was an island in an ocean of catastrophe. What makes these phenomena even more disquieting is the scale of energy they reveal. A supernova radiates with a force greater than billions of suns combined. A pulsar spins with such precision that it challenges our understanding of matter itself. A quasar, powered by a single black hole, can outshine entire galaxies. Each defied the limits of what physics once thought possible. Each proved that the universe is capable of forces far beyond reason, and in each case, first response of science was disbelief. A star exploding brighter than a galaxy? Impossible. A corpse of matter spinning with atomic precision? Nonsense. A black hole swallowing light? Absurd. Yet again and again the evidence forced belief. Telescopes confirmed, detectors recorded, mathematics aligned. Impossible became real. In these revelations lay a deeper, more unsettling truth. Humanity had always imagined power as something earthly, the strength of armies, the might of empires, the brilliance of the sun. But, compared to the cosmos, these were shadows. The real universe was not built for comfort, was built on violence and transformation, on collapses and detonations. Life itself depended on the ashes of stellar deaths. Beauty was carved from catastrophe. This recognition carried with it a quiet terror. If such forces existed out there, what might they mean for us? Could a nearby supernova erase all life on Earth in an instant? Could the slow gravity of a black hole ever reach across light years? The universe was not only powerful, it was indifferent. And within its indifference lay both fear and awe. From that moment on, humanity could never look at the stars in the same way. They were no longer fixed points of light. They were lives, deaths, and unimaginable engines of power. Each twinkle was not a promise of eternity, but a reminder of impermanence. The cosmos was not serene. It was overwhelming, and we had only just begun to understand how violent it truly was. The deeper humanity stared into the universe, the stranger it became. Each new instrument, each extension of vision, stripped away another veil of illusion. What seemed once like distant serenity was revealed as turbulence, as violence, as power. Far beyond comprehension, the naked eye with its limited reach had offered comfort, the illusion of a calm sky. But with glass lenses, metal mirrors, and orbiting observatories, that comfort dissolved into something more overwhelming: truth. When the Hubble Space Telescope opened its eye in 1990, suspended above the Earth's distorting atmosphere, it was as though humanity had been blind until then. For the first time, the stars were seen without the blur of air, sharp as diamonds against an infinite dark. What Hubble revealed was not emptiness, but abundance, galaxies upon galaxies structures, woven across billions of light-years in faint, ancient light stretched by cosmic expansion. What the ancients thought eternal was now measured in time, distance, and decay. The universe was not still, it was unfolding. But Hubble's gift was not only clarity, it was perspective. Looking into deep fields of darkness, Hubble revealed galaxies billions of years old, fossils of light from when the cosmos was still young. Each photon had traveled across unimaginable gulfs of time, carrying whispers of cataclysmic events. Every pinpoint glow was a cluster of suns, many already long extinguished, their deaths echoing faintly into the present. If Hubble gave vision, the Chandra X-ray Observatory gave revelation, where visible light showed stars and galaxies. X-rays unveiled the violent engines hidden inside them. Supernova remnants glowed like cosmic scars. Gas falling into black holes blazed hotter than any furnace on Earth. Entire galaxy clusters revealed halos of invisible plasma, hundreds of times hotter than the core of the sun. The cosmos, when seen in X-rays, was not tranquil but eruptive, sculpted by shock waves and magnetic storms. And then, the James Webb Space Telescope extended the gaze further into the infrared, where the youngest stars are born and the oldest galaxies linger at the edge of time. Webb's golden mirrors captured light stretched thin by the universe's expansion, revealing galaxies so ancient they formed only a few 100 million years after the Big Bang. Structures vast and strange appeared, galaxies merging, stars forming in clouds of dust that once hid them from sight. With Webb, the universe seemed less like a finished cathedral and more like an ongoing construction site, chaotic and magnificent. But telescopes were not the only tools peeling back layers. Instruments tuned to invisible flashes brought revelations even more unsettling. In the late 1960s, American satellites designed to monitor nuclear explosions detected something they were never meant to find.
Alrighty.
Bursts of gamma radiation erupting from random points in the sky. At first, their origin was unknown. They were too bright, too sudden, too powerful. Some lasted only a fraction of a second. Others stretched for minutes. Yet all released more energy than every star in the observable universe combined, concentrated into a single cosmic flash. These gamma bursts are still among the most powerful explosions ever witnessed. Some are thought to be the deaths of the most massive stars, collapsing directly into black holes. Others may arise when two neutron stars collide, shaking the fabric of space-time itself.
Oh.
In those instances, matter is torn apart, magnetic fields twist like serpents, and jets of radiation are hurled across the cosmos at nearly the speed of light. If such a burst occurred too close to Earth, it could strip the planet's atmosphere in seconds. Their very existence challenged imagination. How could a single event rival the brilliance of the universe itself? While telescopes recorded light, another class of instruments searched for what could not be seen: particles. High-energy cosmic rays have been striking Earth for as long as life has existed, their origin shrouded in mystery. Some are born in supernovae, accelerated like bullets, through the galaxy. Others seem to arrive from outside the Milky Way, their energy so high they defy known astrophysical processes. Detectors buried deep underground, suspended in Antarctic ice, or stretched across deserts wait patiently for these messengers. When one collides with Earth's atmosphere, it triggers a cascade of secondary particles, a rain of energy descending silently from the stars. The most powerful cosmic rays recorded carry energies millions of times greater than anything produced. In particle accelerators on Earth, their sources remain uncertain. Do they come from quasars? From colliding galaxies? Or from processes yet unimagined, written into the very structure of space-time? Each detection is both an answer and a riddle. Together, these tools, telescopes for light, detectors for particles, satellites for bursts, weave a picture of a universe that is not passive but restless. Every spectrum of observation reveals new violence. Stars torn apart by tidal forces near black holes. Jets of plasma, thousands of light years long, erupting from galactic cores. Radiation fields that could sterilize entire solar systems. And yet, these revelations carry not only terror but awe. The very atoms of life, the elements of Earth, the possibility of biology, all depend on this violence. Without supernova scattering heavy elements, there would be no planets, no oceans, no DNA. Without the churn of galaxies and the collapse of stars, the universe would be sterile, a place of endless hydrogen and helium, without complexity, without wonder. Each new layer peeled back by science reveals the paradox of power, creation through destruction. Beauty born from catastrophe. The deeper humanity looks, the more it finds that life itself is woven from violence on unimaginable scales. Still, with every answer comes another question. Why are gamma ray bursts distributed as they are? Why do cosmic rays arrive with such inexplicable energies? What role do black holes play in regulating galaxies and shaping the very evolution of the cosmos? Each discovery does not close the mystery but widens it. The more light is cast, the more shadows appear. It is this endless layering that defines the journey of astrophysics. The universe is not a puzzle to be solved once, but a mystery that deepens as it is unraveled. Each new tool does not end the story but begins another chapter. Hubble, Chandra, Webb, and the detectors of particles are not merely instruments. They are extensions of human curiosity, fragile machines reaching across the abyss, pulling fragments of truth from the void. And with every fragment comes the same haunting realization. The universe is far more powerful, far more violent, and far more magnificent than human reason alone can bear. For much of the 20th century, the universe was imagined as a grand but simple stage. Galaxies drifted apart, slowly their momentum set in motion by the fire of the Big Bang. It was thought that gravity, patient and unyielding, would one day decide the universe's fate, pulling it back into collapse or letting it coast forever in slow retreat. Expansion was known. The rhythm of cosmic drift seemed steady, predictable. But then, the unthinkable happened. In the late 1990s, two teams of astronomers set out to measure the rate of cosmic expansion with unprecedented precision. By observing Type Ia supernova, stellar explosions so bright they could serve as cosmic mile markers. They sought to calculate how quickly galaxies were moving apart. Their expectation was simple. The farther a supernova, the more the expansion of the universe should have slowed since its birth. Gravity, after all, should pull back on the fabric of space, restraining its growth. Instead, the data told a different story. Distant supernovae were fainter than predicted. The light had stretched further. The galaxies were receding faster than they should. The expansion of the universe was not slowing, it was speeding up. This discovery was not only surprising, it was catastrophic for human intuition. For centuries, gravity had been the ruler of motion, the dominant sculptor of cosmic form. Now it seemed there was another force, invisible, untouchable, yet somehow stronger than gravity itself, a force accelerating the very fabric of space. Astronomers named it dark energy. The name was a placeholder, a confession of ignorance. Nothing in known physics could fully describe it. It was not matter, not radiation, not any particle cataloged in accelerators. It was not confined to stars or galaxies. It did not clump or cluster. Instead, it seemed woven into the structure of space-time itself, uniform, relentless, pressing outward in every direction, and its scale was staggering. Current measurements suggest that nearly 70% of the entire energy content of the universe is this mysterious, dark energy. Ordinary matter, planets, stars, galaxies, even the atoms of life account for less than 5%. The rest is dark matter, another enigma. But dark energy dwarfs even that. It is the dominant actor, the hidden hand shaping cosmic destiny. For the first time, Scientists had to confront the possibility that the most powerful thing in the universe was not the brilliance of stars, nor the gravity of black holes, but something far quieter, an invisible pressure, expanding the universe itself. This realization shifted the cosmic narrative. Black holes, once thought the ultimate extremes, were revealed as local curiosities compared to the universal dominance of dark energy. A single quasar could outshine a galaxy, but dark energy was everywhere, stretching every quasar farther from its neighbor. Supernova could release unimaginable power, but dark energy worked not in bursts but in permanence, an eternal, steady push. Subtle, yet overwhelming, and with this came dread. If the universe's expansion is accelerating, what does that mean for its future? Will galaxies one day be pulled so far apart that no light from beyond our own will ever reach us? Will stars burn alone in endless night, their brilliance extinguished in a desert of silence? Or could dark energy grow stronger still, tearing apart galaxies, then stars, then even atoms themselves, a fate some call the Big Rip? The answers remain uncertain. Measurement suggests that dark energy behaves like a constant, echoing an idea first proposed by Einstein as the cosmological constant. In his time, he introduced it reluctantly, then discarded it, calling it his greatest mistake. Yet perhaps it was no mistake at all. Perhaps he had glimpsed, through mathematics, the quietest and most powerful force in the universe. Still, alternative theories abound, a dynamic field that shifts over time, property of quantum vacuum energy, or even evidence of dimensions. Beyond our own, the mystery deepens, not only in theory, but in observation. Telescopes like Hubble and now the James Webb continue to refine measurements of supernovae and galaxies. And new instruments such as the Vera Rubin Observatory and the Euclid mission are designed to chart dark energy's fingerprints with even greater clarity. Yet the more precisely the universe is measured, the stranger it seems. Recent data has revealed tensions between different methods of measuring cosmic expansion. The Hubble constant, the rate at which the universe grows, appears to differ depending on whether one observes nearby galaxies or the ancient cosmic microwave background. This Hubble tension may be a clue or a warning that something profound is missing from our understanding, and so the hierarchy of cosmic power has shifted. Once, supernova seemed ultimate, then quasars, then black holes. Each new discovery revealed a larger stage, a deeper force. But now, with dark energy, the universe itself appears as the arena of greatest power, not in singular events of fire or collapse, but in the silent rewriting of space and time. The tension lies in its invisibility. The most powerful force in the cosmos cannot be touched, cannot be seen, cannot even be defined. Its presence is inferred only through the way galaxies flee from one another, faster and faster. It is the hand unseen, the quiet tide that carries all things outward. And here lies the philosophical weight. If the most powerful thing in the universe is not an explosion, nor a singularity, but a quiet expansion, what does that say about the nature of power itself? Is the ultimate force not destruction, but persistence? Not violence, but inevitability? Perhaps the cosmos is telling us that true power does not roar, it whispers, does not blaze for an instant, but endures forever, the universe once imagined. As eternal and unchanging, is now revealed as dynamic, restless, driven by something both everywhere and nowhere. Humanity, fragile and small, must reckon with this new order, that the very space between atoms, between galaxies, between all things, is swelling with energy beyond comprehension. The mystery is not over, it is only beginning. For if dark energy is indeed the most powerful thing in the universe, then the universe itself may be stranger than even imagination allows. And if it is not, if something deeper still hides beneath its mask, then perhaps we have yet to glimpse the true engine of creation and destruction. The question remains. Haunting and unresolved, is the cosmos ruled by the bright violence of explosions, the crushing grip of black holes, or by the silent hand of dark energy, the invisible force pushing everything apart? In that uncertainty lies both terror and wonder. For the mystery of cosmic power has not ended. It has only escalated. The question lingers like a shadow across the cosmos. What is the most powerful thing in the universe? Each discovery has unveiled candidates, each one seemingly insurmountable, yet each surpassed by something greater, more elusive, more profound. To search for an answer is to journey through the hierarchy of extremity, comparing the brilliance of explosions, the precision of beams, the gravity of monsters, the silence of expansion, and the birth cry of creation itself. The first contenders are the titans of stellar death, supernova and hypernovae. When a massive star exhausts its fuel, fusion falters, and gravity takes command. In less than a heartbeat, the core collapses. Temperatures soar to billions of degrees, matter is compressed beyond recognition, and shock waves rebound outward. The star detonates in a cataclysm so fierce that for weeks it can outshine entire galaxies. These explosions scatter heavy elements across interstellar space, seeding the clouds that will form new stars, planets, and, eventually, life. Without them, the universe would be a barren sea of hydrogen and helium. In raw energy, a supernova releases more in seconds than the sun will in 10 billion years. Hypernovae, the even rarer collapse of the most massive stars, push this scale further still. They are detonations of unimaginable ferocity, the most violent stellar deaths known. Yet, even their fury pales before another contender. Gamma bursts. These are the universe's briefest, most concentrated beams of destruction. In moments lasting from milliseconds to minutes, they unleash as much energy as the rest of the visible universe combined. Some are thought to arise when neutron stars collide, their merger producing both a black hole and a flood of heavy elements. Others may be born when a hypernova collapses, channeling its death into jets that pierce through space like cosmic lances. A gamma burst aimed directly at Earth would strip away the atmosphere and boil oceans into steam. Fortunately, their beams are narrow, their victims few. Yet the scale of power in so short a time remains staggering. Among all known cosmic events, none shine brighter. Beyond explosions lies endurance. Supermassive black holes, crouching at the centers of galaxies, are engines of persistence. Millions to billions of solar masses compressed into regions no larger than a star system, they warp the fabric of space so deeply that not even light can escape. Yet paradoxically, they are also sources of some of the universe's greatest brilliance. As matter spirals into their gravitational grip, it heats to extraordinary temperatures, radiating across the spectrum. Quasars, powered by these cosmic monsters, can blaze brighter than trillions of stars. Their jets, streams of particles accelerated near light speed, extend for thousands of light years, sculpting the galaxies around them. Unlike the fleeting fury of supernova, black holes dominate for billions of years. Shaping the architecture of the cosmos itself, they are destruction made eternal, violence turned into structure. But even black holes, with their infinite gravity, cannot rival what was revealed in the final years of the last century: the accelerating expansion of the universe, dark energy. Invisible, yet overwhelming, now appears to be the dominant power of existence. It does not burst, or beam, or collapse. It whispers, constant, patient, irresistible. Its strength is not in violence but in ubiquity. It is everywhere, woven into the fabric of space-time, pushing galaxies apart, stretching the universe itself. Nearly 70% of all that exists is this unseen pressure. Compared to it, stars, planets, even black holes are fragments, minor details in a far larger design. If its influence continues unbroken, it will dictate the ultimate fate of everything, a future where galaxies vanish beyond sight, where the night sky grows empty, where even atoms may one day be torn apart by cosmic acceleration. It is power not as explosion, but as destiny. And yet, perhaps all of these contenders are but echoes of the greatest power of all, the Big Bang. Not an explosion in space, but the explosion of space itself. The beginning of time, when the universe erupted from a singularity into existence. In less than a second, reality expanded faster than light, in a surge known as cosmic inflation. Temperatures soared beyond imagination. Particles and forces emerged from the quantum storm, and the seeds of galaxies were planted in the froth of primordial fluctuations. All power since every supernova, every gamma-ray burst, every black hole, every whisper of dark energy is but the unfolding consequence of that single moment. If there is an ultimate crown of cosmic power, it belongs to the beginning when nothing became everything. Yet here lies the philosophical weight. How can power be measured? By intensity, then gamma-ray bursts reign, by endurance. Holes hold dominion, by influence, then dark energy commands. By origin, then the Big Bang is supreme. Each candidate reshapes the definition of power itself. Supernovae give power its creative face, the violence that births the elements of life. Gamma-ray bursts give it precision, the sharpness of beams that can unmake worlds.
While black holes
Embody gravity's extremity, the collapse of matter, and the sculpting of galaxies. Dark energy is persistence, the steady hand guiding the universe's future. And the Big Bang is Genesis, the act of creation that made all others possible. Perhaps the truth is not that one is the most powerful, but that power itself wears many masks. Creation and destruction, instant and eternity, visible and invisible. The universe resists a single crown. It is a hierarchy of immensities, each greater than what came before, each defying human imagination. And in that resistance lies a deeper reflection. Power in the cosmos is not absolute. It is layered, contextual, evolving. The most powerful thing is not any single phenomenon, but the principle that power itself shifts from explosion to persistence, from destruction to expansion. Humanity's search for the ultimate force is not only about the universe, it's about understanding the limits of thought, the boundaries of imagination, and the humility of knowing that even our greatest definitions may be too small for the truth. The candidates remain before us. The stars that die in brilliance, the beams that ignite the void, the monsters that consume and shine, the silence that stretches space-time, and the birth that gave rise to it all. Which among them is supreme? The answer slips like light through the fingers of comprehension. And perhaps that is the true power, not only to shape the cosmos, but to leave the human mind in awe, suspended between terror and wonder. To chase the most powerful forces in the universe is to stretch the limits of human ingenuity. For the cosmos does not reveal its secrets easily. Its engines of power lie hidden behind distances measured in billions of light-years behind matter, so dense that even light cannot escape, behind energies so immense that no laboratory on Earth can replicate them. And yet with fragile machines built by mortal hands, humanity has begun to listen, to see, and to measure. The first of these instruments are not eyes, but ears. Colossal detectors, attuned not to light, but to the trembling of space-time itself. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, captured a signal unlike any heard before. Two black holes, each dozens of times more massive than the Sun, spiraled together and collided. The violence of that merger released more energy in a fraction of a second than all the stars in the observable universe combined. Yet this power was not radiated as light, but as ripples in the fabric of space and time. LIGO detected those ripples as a faint stretching and squeezing of its 4-kilometer arms, smaller than the width of a proton, yet enough to prove Einstein's century-old prediction true. Since then, LIGO and its European counterpart Virgo have recorded dozens of such events. Black holes colliding, neutron stars merging, space-time ringing like a cosmic bell. Each detection expands the frontier of knowledge, revealing not only the existence of invisible cataclysms, but the physics that governs them. These observatories remind humanity that the universe speaks not only in light, but in gravity, in vibrations that ripple through reality itself. If LIGO and Virgo are ears pressed to the universe, then the James Webb Space Telescope is an eye gazing deeper than ever before. With its golden mirrors unfolding in the cold silence beyond the moon, Webb has begun to glimpse the first galaxies. formed when the universe was less than 500 million years old. Its infrared vision pierces the dust where stars are born and stretches into wavelengths invisible to the human eye. Already, Webb has revealed galaxies larger and more complex than expected at such an early epoch. Challenging theories of cosmic formation, it peers into the atmospheres of distant exoplanets, searching for chemical fingerprints that might whisper of life. But above all, it looks back toward the dawn of time, when the first structures emerged from the primordial fog. In Webb's data lies the possibility of tracing the very fingerprints of cosmic power etched into the light of the earliest stars. On Earth, beneath mountains and buried in tunnels, another frontier is pursued. Particle colliders, like the Large Hadron Collider near Geneva, recreate in miniature the conditions of the early universe. By smashing protons together at near-light speeds, physicists probe energies unseen since the first trillionths of a second after the Big Bang. It was here that the Higgs boson was discovered in 2012, confirming the mechanism that gives particles their mass. But even greater mysteries remain. Could collisions reveal particles of dark matter, the unseen mass that binds galaxies? Could they hint at the nature of dark energy, or reveal hidden dimensions? Each collision is a glimpse into the machinery of creation, a controlled spark of the fire that once set the universe ablaze, and the search does not stop there. New missions are being built to measure the universe's deepest signals with unprecedented clarity. Satellites like Euclid, launched by the European Space Agency, and the Nancy Grace Roman Space Telescope, planned by NASA, are designed to chart the structure of the cosmos across billions of light years. By mapping the distribution of galaxies and the bending of light through gravitational lensing, these missions will probe the fingerprints of dark energy, testing whether it is constant or changing, uniform or evolving. The Vera Rubin Observatory in Chile, with its vast survey of the night sky, will capture the shifting dance of billions of stars and galaxies, revealing transients and anomalies never before seen. Other instruments look even further back, to the faint afterglow of the Big Bang itself. It's the cosmic microwave background radiation, older than any star, older than any galaxy, is a fossil of the universe's birth. By measuring its subtle fluctuations, scientists can test theories of inflation, the moment when space itself expanded faster than light. Future missions aim to map this background with exquisite precision, searching for the faint polarization patterns that could confirm the fingerprints of primordial gravitational waves, echoes from the universe's first instant. If found, they would be the oldest evidence of power ever detected, proof of energies beyond imagination written into the birth of time. And yet, some tools turn not outward, but inward, to black holes themselves. The Event Horizon Telescope, a network of radio observatories spread across the Earth, has already produced humanity's first direct images of black holes. The glowing ring of matter around the monster at the heart of galaxy M87, and the shadow of the supermassive black hole at the center of the Milky Way. These portraits are not just images, but confirmations that space-time bends and swirls exactly as Einstein predicted. Future versions of this telescope, sharper and more sensitive, may reveal the dynamics of plasma and magnetic fields as they dance at the edge of the abyss. They may even test whether black holes behave as general relativity demands, or whether cracks in the theory emerge in the presence of ultimate power. Together, these instruments, LIGO and Virgo, Webb and Hubble, colliders and satellites, telescopes of Earth and space, form a web of human curiosity stretched across the cosmos. Each tool is fragile, finite, built with budgets and deadlines, vulnerable to failure. Yet through them, the universe is revealed with a clarity no generation before could imagine. Each detection, each image, each signal is a fragment of a story, far greater than humanity itself. There is something humbling in this pursuit. To measure forces that could erase worlds, to chart distances so vast that light itself ages across them, to probe energies no human body could endure, and yet to do so with mirrors, lasers, magnets, and circuits assembled on a small planet, orbiting an ordinary star. It is an act of defiance against ignorance, but also an act of reverence. For science is not merely the accumulation of data. It is a dialogue with the cosmos, a patient listening to whispers of unimaginable power. Quest is not finished. Each new tool brings answers, but also new mysteries. Gravitational waves reveal collisions, but suggest populations of black holes larger than expected. Webb uncovers galaxies too massive too early, challenging models of cosmic evolution, colliders. Confirm the Higgs, but leave dark matter and dark energy untouched, as if mocking human limits. The universe yields truths, but never the whole truth. And so the search continues, relentless. For to understand the most powerful thing in the universe is not only to satisfy curiosity, it is to understand destiny. Dark energy may dictate the fate of time itself. Black holes may hold clues to the unification of physics. The Big Bang may whisper answers about existence itself. Each measurement is a step toward comprehending what power truly is and what role humanity plays within it. Perhaps, in the end, these instruments will not find a single ultimate force. Perhaps they will find only layers upon layers, each power feeding into another, each mystery birthing deeper questions. But even if the crown remains elusive, the pursuit itself is a revelation that fragile beings of flesh and bone bound to a small world can extend their senses into the very fabric of creation. The most powerful thing in the universe may remain hidden, but the act of searching with telescopes, detectors, colliders, and satellites is itself a testament to another kind of power, the power of curiosity, of persistence, of the human spirit daring to measure the immeasurable. The search for the most powerful thing in the universe leads not only outward, but inward. For every discovery, every supernova, every black hole, every whisper of dark energy forces humanity to turn the question upon itself. What? After all does it mean to speak of power in a cosmos where scales dwarf imagination, where energies rewrite the fabric of reality, where destruction and creation are inseparable? Power has always seemed obvious in the human story. It was the strike of the hammer, the strength of armies, the command of kings. But when measured against the stars, these vanish into dust. A single Gamorre burst, invisible to the eye, carries more energy than all the wars and empires of Earth combined. The crushing pull of a black hole bends even light to obedience, a dominion no ruler could ever dream. In this comparison lies humility, and in humility, reflection. Perhaps true power is not in violence, but in paradox. Supernova destroys a star, yet in its ashes are born the elements of life. Iron in the blood, oxygen in the lungs, calcium in the bones, each a relic of stellar death, stilling in their annihilation. Stars give more than they take. Power here is not finality, but transformation, the Big Bang itself. That first unfathomable instant embodies another paradox. It was the most violent moment imaginable, yet it was not violence for its own sake. It was creation, time, space, energy, matter, all rushing into being from a singularity beyond comprehension. It was the greatest outpouring of power the universe has ever known, yet its legacy is not destruction. Its legacy is galaxies, stars, planets, oceans, forests, and minds that can wonder. In its chaos, it laid the foundation for order, and yet there is another kind of power, more elusive, more unsettling. It is not in fire or collapse, not in jets of radiation or walls of gravity, but in silence. It is the expansion of the universe, itself invisible, patient, unstoppable. Dark energy does not roar, it does not explode, does not announce itself with brilliance. Instead, it stretches space-time, carrying galaxies away from one another, slowly emptying the night sky of its stars. Its triumph is not in a moment, but in inevitability. It rules not by force, but by persistence. If power is defined as the ability to shape destiny, then dark energy may hold the ultimate crown. And here the paradox sharpens further. For if the most powerful thing in the universe is not destruction, but expansion, not fire, but silence, then power itself is not what humanity once believed. It is not the blow that ends, but the tide that endures. It is not a flash of brilliance, but a principle woven into the bones of reality. Where, then, does this leave humanity? Fragile beings living on a thin crust of rock, warmed by a single star, vulnerable to forces beyond all resistance. A nearby supernova could extinguish life in an instant. A gamma ray burst, if aimed directly, could erase the biosphere. A black hole, silent and unseen, could wander close enough to tear apart the solar system. Even without such catastrophes, dark energy promises a future where galaxies vanish into darkness, where time stretches toward a cold and lonely end. Yet in this fragility lies something profound. For out of this same cosmos that wields such unimaginable power, consciousness has emerged, delicate, temporary, yet capable of reflection. Against the violence of stars, thought itself seems weak. That it is through thought that the universe becomes aware of its own immensities. A collapsing star does not know it has exploded. A black hole does not know it has devoured light. But within human minds, the universe contemplates itself. In this, fragility becomes another kind of power, perhaps the greatest paradox of all. Is that the most powerful thing in the universe may not be an event, or a force, or even a principle, but the dialogue between immensity and awareness. For what is the measure of power without something to witness it? To give it meaning, without consciousness, the cosmos is magnificent, but silent. With consciousness, its power becomes awe, terror, wonder. And so the question remains unresolved, suspended like a star on the horizon. Is the crown of cosmic power held by the detonations of supernovae, the beams of gamma ray bursts, the gravity of black holes, the persistence of dark energy, or the singularity of the Big Bang? Or is the answer not a thing, but a truth that power wears many faces, each indispensable, each beyond human scale? The universe evolves beyond imagination. Perhaps that evolution itself is the ultimate force, a principle that nothing remains still, that all things transform, that existence itself is restless. In the end, the search for the most powerful thing in the universe may not lead to a single answer, but to a haunting reflection. Power is creation and destruction. It is silence and fire. It is the beginning and the end. And within it, humanity is both insignificant and essential, a brief flicker of awareness in an ocean of immensities. If the universe itself is power, then what role does fragile human consciousness play within it? Perhaps to measure, to wonder, to bear witness, perhaps to remind the cosmos that in its vast, indifferent unfolding, there is also meaning. The question lingers, to answered echoing through the silence of the stars.